Okay, the last part of this week, okay, we are going to learn about elastic and inelastic collisions. Okay, so what we learned before, okay, is the conservation of momentum. Okay. The total momentum before must be the same as the total momentum after. No matter what, if it's a collision, the total momentum before must be the same as the total momentum after. Okay, but there are two types of collisions. Okay, now type 1 we call it elastic collision. Okay. So elastic collision is when the total kinetic energy before equals to the total kinetic energy after. Okay, just um, just remember, okay, in physics, in the chapter of motion, we're dealing with forces, we're dealing with momentums. Also, we have to deal with kinetic energies. They're all different. Okay, they're all different. Don't get them confused. Okay, if this happens, if the total kinetic energy before is the same as the total kinetic energy after, okay, it means an elastic collision. Okay. Now, if not, we call it an inelastic, okay, collision. Okay. Inelastic collision means the total kinetic energy before is not the same as the total kinetic energy, total kinetic energy after. Okay. What happened was some energy are lost during the collision. Okay, here are the definitions. Now, just let me show you some questions. Okay. Now, let me just do this. Now, an object mass of this, m1, okay, moving like this, v1 before, okay, use this one, collide with a stationary object, so v2 before will be 0, okay, mass this. Okay. After the collision, object A recoils with the speed of this. Okay. Now, so that's v1 after, while object B, so that this is your v2 after. Okay. Is the collision elastic or inelastic? So let's do a calculation. Okay. Now, total kinetic energy before. Now, the equation for kinetic energy, Ke will be half mv square. Okay, we'll do that in detail next week. Okay, so let's do this first. Okay, before. So kinetic energy before, okay, will be half mass number 1, okay, v1b square plus, okay, now half mass number 2 V2B square. Put it in. Mass B is 0. Okay, so this will be 0 and 9 joules. Okay, afterwards, this is after. Okay, now will be half and 1 V1 after square plus half M2 V2 after square. So put all the values in. Sorry, made a mistake. My M1 is 2 here. Okay. Now V1 after will be 0.3 plus 2.2. Now what we can do is, so I have 0.09. Okay. You need to use the calculator again. 3 divided by 2 times 2.2 times 2.2. Okay, so it's going to be 7.26 and sum up 7.35 joules. Okay, so as we can see, okay, from this, as we can see, okay, now the total kinetic energy before is not equals to the total kinetic energy after. Okay, so it is inelastic. Okay. Now let's do this question here. Okay, this is a past exam question. Now, a locomotive, okay, mass of this. Oh yeah, we have it on the diagram. Okay, was this collision elastic or inelastic? Okay, now in order to do this, we need to find out if we read the diagram. Okay, that's before. Okay, now after they collide, the whole thing moved together. So we need to find out the speed, okay, the velocity after first. Okay, so what we do is use a conservation of momentum. So the mass, okay, the mass are all the same. So m times v plus 3m, because this time is 3, okay, times 0 equals to, when these fall together, 4m. Okay, that's the mass. Okay, so it's 4m times v after. So I have mvb equals to 4mva. Okay, if we cancel out the equation, VA will be VB divided by 4, which is 8 divided by 4, 2 meters per second. Okay. Then afterwards, let's find out whether it's elastic or not. Okay, so that's before. Before, the total kinetic energy, okay, will be half m8 square, okay, plus 0, because those parts, they are at a rest, they're not moving. Okay. It will be half times 64. Okay, now put it in the calculator, it will be 40123 joules. Okay, now have a look at afterwards. Okay, now we'll have half. Okay, the mass will be 4m, okay, times 2 power of 2. So I have 4 times 4. Okay, so I have 8 times 3. Sorry. Now it will be 160,000 joules. Okay, so yep. Before they're not equal. Since they're not equal, so it's inelastic. Now, just a quick reminder, in the exam, you always have to mention this. Okay? Because they are not equal, then we have that. If I'm marking the exam, okay, a 3-mark question, okay, you get this, 1 mark, you get this and this, mention 1 mark, then you write down that, you get 1 mark. Also, normally it would be, I gave it 4 marks, so the final answer will be another mark. Okay, if you're missing this part, you losing a mark. You have to mention because the total kinetic energy is different. Okay, sorry, the total kinetic energy before is different to the total kinetic energy after.